Hello everybody and welcome to another shader graph tutorial. In this tutorial we are going to look at the technique for screen space refraction. And the difference between this one and the one I showed before, which was based on the tangent space, is you can see this one is the tangent space, and you will have problems sometimes where the seams of the faces are, right? Because the tangent, I think because the tangent cannot be calculated accurately or something like that. And so when you do it screen space, it does not matter where you are looking at the object from, basically. Also, as an added bonus, you can see that the more refraction, you will have the channels for like the red and blue and green getting split, which gives this nice effect. You can make it more obvious or less. You can see it here as well. And you can change the index of refraction as well. Right? But I prefer it like that. Alright, so let's just jump into the graph. And it looks like this. What I am doing is I have this subgraph that I'm going to show you right now, which takes the index of refraction that you want and outputs the refracted scene color, right? Which is basically what the camera is rendering. Obviously, you have to set your material to be transparent, and you will have to have your opaque texture enabled in the URP settings, right? And as you can see, I have 3 of these. Each one, the first one takes the index of refraction as is. The second one just adds this add parameter that we have, and so we add some index of refraction to the second one, and we add double that amount to the third one. And then you just take the red from the first, green from the second, and blue from the third. You can obviously change the order. It kinda doesn't matter much, but yeah. So to go to this subgraph, it's this one here, right? And as always, we have the same setup for refraction to begin with, which is view direction, normal, vector, and the index of refraction. The view direction is the vector from the camera to the pixel that we are rendering, and the normal is the normal of that geometry. You can obviously also add a normal texture and blend it with this one before you connect it, so that the normal texture that you apply to your shader is also affecting the refraction. And then the custom function is I'm using string. You can create a file. It takes these 3 and then it does this refract function, which is built in to HLSL, normalizes both view and normal, and passes these 3, view, normal, and then IOR, index of refraction, and assigns it to the output, right? Now the output, I am adding the position of that pixel that we are rendering to this output, normalized as well, which means that we refracted the vector from the camera to the pixel, right, by the geometry, and then we are adding it to that position in world space, right? Now when we transform world space alone from world space to screen space, and then we assemble or we sample the scene color, it's just gonna look like it is transparent, right? Because that's what's actually this node does, which is the screen position. This node gets the position in world space and then transforms it into screen space, and that's your output here. And so if you use this, it's just gonna look transparent, right? However, what we did is that we changed the position to the refracted position, and then we transformed it from world to screen space. And the transformation looks like this. You will have to split your vector 3 and assign the W to 1 in order for the multiplication by the transformation matrix to work. And this guy also has to be the upper parameter. If you switch them, it might not work properly. And so to begin with, this view projection, as far as I understand, transforms from world to clip space, right? So here we have clip space, and then this custom function takes a vector 4, outputs vector 4, and it doesn't matter what's the name of the function is, and it uses this also built-in to Unity function, compute screen position, which transforms our input, a clip space input, and it takes the x of the projection parameters, which is, as far as I remember, is the width of the screen. And so this function transforms our input from clip space to almost screen space. All what you still need to do is to divide your x and y by the w, and then you will have your screen space over here, right? So this is going to give us the refracted screen space position, right? And then just connect it to the scene color, and then that's your output. It's as simple as that. You can obviously again get your normal texture and blend it with this normal vector, and the output can be multiplied by your albedo texture to have a blend between, or a tint, I guess, between your refraction and an albedo texture. But yeah, that's the basic idea. And if you don't want this effect of splitting the channels, you can just have one of these, right? And connect it. As easy as that. Yeah, so this is going to be for this tutorial. Thank you so much for watching, and consider liking and hitting the subscribe button. See ya.